Good morning. In this video, we will be discussing the disk scheduling algorithm, which is first come first served, FCFS. Assume that the queue contains the list of the request to set of cylinders and the head is at the cylinder number 53. And let's see how the first come first served works to satisfy the request and what will be the total head movement. So we'll be calculating the total head movement. Okay. The question says the head is at cylinder 53, so you are going to start from 53. And the request, you need to go along with the request because the algorithm is first come first served. So which comes first will be received, served first. In the queue, you have the request for the cylinder, so you will be following the same request in the queue. Okay, you will follow from the beginning to the end. So first from the cylinder current position, it goes to 98. So better put it in the straight line when you draw the uh, disk scheduling. Okay, from 98 to 183, here it is. And from that 37, so it goes back to the beginning because 37 is somewhere here. After that 122, so it's somewhere here, 122. And 14 goes back here. After 14, 124, it's somewhere here, for example. And then 65, it's somewhere here. And then 67, so 67 is here. So in this way, the head will move from one cylinder to another cylinder based on the request in the queue. It goes from 53 to 98, then 183, and then back to 37, and then 122, and then back to 14, and come back to 124, go back to 65, and then 67. Now we need to calculate the total head movement. Let me write it in short form, THM, total head movement. So you need to calculate the head, movement of the head from where to where. So because we are going to calculate the number of cylinders it traveled. Okay, so at the beginning it was in 53, from 53 it went to 98. So subtract 98 minus 53. Plus from 98 it goes to 183. So from 183, 98 we subtract. Plus from 183 it goes to 37. 183 to 37. So big minus small. Okay. Plus from 37 to 122. So 122 minus 37. From 122, cylinder 14 plus from cylinder 14 to 124 plus 124 to 65 plus 67 and then 65. So these are the distances or cylinders the head moved. Okay, so when you subtract 98 minus 53 and then 183 minus 98 and goes on, we get this number 45 plus 85 plus etc. When you add them all, you will get 650. So this is the answer. Total head movement is total head movement is 650 cylinders. Okay, the next disk scheduling algorithm is shortest seek time first, SSTF, disk scheduling algorithm. So here in the shortest seek time first, it will select the request with the minimum seek time from the current head position. Let's say the current head position is 53. it will go to the nearest one. It won't go to the very far one and come back here. It will go to the nearest location. So which is near maybe 65, 67. So it will accomplish the nearest positions rather than looking for the longer one. Okay, so this is the idea. It will look for the minimum seek time from the current head position, the closest one. Okay, closest cylinders. It will serve the request which needs to read or write nearest cylinders. Fine. So the question says the head is at the cylinder number 53 and this is the queue contains the request for the cylinders. The same queue I considered which I used for the first come first served. So let's see what will be the total head movement and we'll compare this with the first come first served. So current head is at cylinder 53. Now look into the queue which will be the closest one for 63 from 53. So from 53 which will be the closer one? Of course 65 is the closer one. So the next request will be for 65 and from 65 the closer should be 67 because only 2 cylinders to move. From 67 we can look for the closer one. Okay, the closer is maybe the 98 or 37. So when you compare when you see the distance, the number of cylinders between 67 and 98 is 31. But when you look for 37, when you subtract, you will get 30. So the closer is 30 instead of 31. One cylinder bigger. So don't go to 98. Don't go here. 37. You need to subtract so that you can get the idea. See, from 67 to 98, we need 31 cylinder movement. We need to move 31 cylinders. Okay. When you go from 67 to 37, 30 cylinders movement. Okay. So we will be choosing 37. From 37, the closer one is 14, of course, because the other requests are 98, 122, 124. They are far away. The closer is, of course, 14. And from 14, the next movement will be not 183, not 124, not 122, the 98. This is the next closer cylinder. And from here, of course, the next request will be 122, followed by 124, followed by 183. Okay, remember total number of cylinders here are 200. So cylinder starts from 0 to 199. So 200 cylinders are there and the queue contains the request to these cylinders. And the current head position is at cylinder number 53. So from 53 you go to the closest cylinder. The head will move to the closest cylinder. Okay, so among the request, which one will be the closest? You need to subtract like 65 minus current position 53 or 55 to 37. So you need to find out. You need to subtract which one will have a smaller number of cylinder that will be selected for the next request. Okay, so in this way shortest seek time first will work. And let's calculate the total head movement. Same like before, you need to subtract the movement of the head from cylinder to cylinder. So first movement was from 53, it went to 65. So 65 minus 53. The next movement of the head from 65 to 67. Subtract the big minus small. From 67, it went to 37. and from 37 to 14. From 14 to 98. From 98 to 122. And from 122 to 124. And from 124 to 183. So let's calculate the difference, like the subtract. Here it is 12, this one is 2, this one is 30, this one is 23, this one is 84, this is 24. The difference, I'm talking about the difference. Here it is 2 and the last one is 59. When you add them all, you get 236 cylinders. So this is the total head movement. Let me write it in short form, THM, total head movement. Do you get the idea? So, sorry, you couldn't able to see that. Yeah, now it's visible. Okay then, so this is the way we will be solving the shortest seek time first algorithm, scheduling algorithm. When you are given the queue and the head position, you can able to solve using the SSTF algorithm. And how to calculate the disk movement, total head movement in this way. You need to subtract the head movement from where to where it went. First movement is from 53 to 65. Next movement and then next movement. So you subtract the cylinder numbers in each movement and you will get one number. That's the total head movement. Okay, the next one is scan scheduling algorithm. So here in scan scheduling algorithm, the disk arm starts at one end of the disk and moves towards the other end of the disk, servicing the request while it moves from one end to another end of the disk. Okay, so this is the idea of scan. So the head movement is reversed and it serves the request. So that's the idea. Another name for scan scheduling algorithm is elevator algorithm. So what will be the total head movement for the same request string in the queue, and head position is at the cylinder number 53. The same question we will try to solve using scan scheduling algorithm. Okay, so let's see. I was telling that the disk arm starts from one end to the other end. So assume that the disk is moving towards 0. Let's assume this is the current position and the disk arm is moving towards 0. So you will be moved to the end and then come back. This is the idea of scan algorithm. It will move, the arm starts at one end of the disk and it moves towards the other end. While it moves, it serves the request as it reaches the cylinder. Okay, while it goes through the cylinders, it tries to serve the request. So that's the idea. Let's assume that the disk arm is moving towards 0. So towards 0. So this is towards 0. Okay, so while moves towards 0, it tries to serve the request. So the next service will be for disk cylinder 37, and then it serves 14. And it, you know what the idea of scan is, it goes to the one end of the disk. Okay, it goes to the one end of the disk and it travels backward. When it backward, it serves 65, 67, 98, 122, 124, 128, 183, and it stops here. There is no more request after 183. Okay, so it moves to one end of the disk, extreme end of the disk, and from that it travels to the other end. while it is moving to the disk end of the disk and it travels to the other end, while it is moving, it serves the request on the way. So this is the idea of scan scheduling algorithm. So let's try to calculate the total head movement. Can you see here, it was here 53 and it moves to 37, 14 and it moves to 0. So instead of moving each item, I'll just subtract from 53 to 0. Okay, this is one movement I can consider because it's all in one same direction. Okay, so it's a faster way. Plus from 0 it moved to 183. Is it? So 183 minus 0. So 53 plus 183, that's equal to 236. So this is the total head movement, 263 cylinders. Okay. So the idea is the simple for scan scheduling algorithm. From the current position, it moves to the end of one end of the disk. While it moves to the end of the disk, it serves the request on the way. And if it reaches the one end of the disk, it travels back to the other end. While it moves to the other end, it serves on the way other request. Okay, and this is the last request 183. After that there is no more request. Okay, so it stops here at 183. Okay, the next algorithm is C-scan scheduling algorithm. Okay, let's go to the scan scheduling algorithm, the one we saw before. In scan scheduling algorithm, assume that the disk arm moves towards 0, so it serves the two requests on the way, 37 and 14, and while it returns back to the other end, it serves the other 6 requests, 65, 67, 98, 122, 124 and then 183. So this is the high density of request. High density means more requests are here after the current position. So the head is at position 53. This is the current position. So from the current position in the backward there are high density of request. I mean more requests, and in the front part there is less density of request. But here in scan it moves towards 0 and comes back. So the high density of requests are to wait for a longer time. So the disk arm moves towards the 0 and then comes back here. So they were waiting for a long time, this high density of request. So a solution to this is C-scan scheduling algorithm. Here in the C-scan scheduling algorithm, the high density of request will be solved. Okay, so from the head position, current position, disk will move towards the to the end, the other end of the disk. While moving to the other end, it tried to serve the request, and after reaching, so let's assume 183 is the last request in the second half of the disk. So then after reaching 183, it moves back. While it moves back, that is what you call traverse back. That time it will not serve any request. Okay, so while it traverse back, no request will be served. So that is one thing you need to remember. Head moves from one end of the disk to the other end. While it moves to the other end, it tries to serve the request. When it reaches the other end, it immediately returns to the beginning of the disk. Okay, when it returns to the beginning, when it traverses back, it will not serve any request. It is a trip, return trip. It just go to the beginning of the disk. That's it. No request will be served. So it treats the cylinder as a circular list that wrap around from the least cylinder to the first one. So sorry, the last cylinder to the first one. Okay. So remember this while we try to solve. Okay, so here this request Q has a list of requests. So current position is 53. From 53, it goes to 65 and then 67 and then 90, 98 is somewhere here. Okay. And from here it goes to 122, 124 and 183. Here it is. Okay. When it reaches the end, after this there is no more request, is it? But you know, it won't stop here. It will go and go to the end of the disk, which is the 199. Remember, okay, it goes to other end of the disk, like the scan algorithm. In the previous scan algorithm also, it touches the other end, 0. It moves to 0 and then comes back. So here it goes to the other end of the disk and it returns. Remember, while it returning, it's a return trip. It is not going to serve anything. It will just return to the beginning of the disk, which is 0. While it returns, okay, the direction is, it goes like this. So if you want, I can write the direction. It goes like that and it goes like that. While it returns, it will not serve anything. But we still have two more requests, one for 14 and one for 37. So other two requests will be done after it returned to 0. From 0 it serves. So can you see one thing? The requests are served in one direction. So when it moves from left to right, it serves the request. When it moves from right to left, it's not serving the request. Left to right, it serves the request, not right to left. Is it clear? So let's see the total head movement, THM, total head movement for this example. Okay, very simple. It moves from 53 to 199. So I can straight subtract 199 minus 53. Okay. By the way, from here to here it moves. That is not going to be counted. Okay, I'm not going to write it. And from 0 to 37. So let me write 37 and then 0. This distance is not going to be counted because during the time it's a return trip. No requests are served. So what is the answer? 146 when you subtract this, plus when you subtract this you will get 37. When you add these two you get 183 cylinders. Okay, so this is the idea. So the disk moves from the current head position to the end of the disk. The head moves from the current position to the end of the disk. This is the extreme end of the disk. When it reaches the extreme end of the disk, it travels back to the beginning of the disk. While it travels, it is not going to serve any request. And from the beginning, it continues to serve the pending request. Is there any pending request in that or continued? Okay, so in this way, C-scan algorithm works. So the next scheduling algorithm is C-look scheduling algorithm. So the difference in C-look scheduling algorithm is very similar to C-scan scheduling algorithm. C-scan means circular scan, by the way. So here in C-look algorithm, the difference between the C-scan and C-look is, in C-scan, from the head position, it moved toward the end of the disk. It moved towards the end of the disk. After reaching the end of the disk, it moves to the beginning of the disk. So here, that travel distance are reduced by not going through the end of the disk. It's not going through to the end of the disk. It won't go to the end of the disk. Rather, it will move until the last request. After reaching the last request, it travels back. So that's the idea of C-look scheduling algorithm. Let's see. As I write only the request on the top, we don't have to bother about this one. We just go with the number from disk arm position 53. It goes to 65 and then to 67 and then to 98 and 122, 124 and then it goes to 189 or these directions. Okay, let me draw the direction. 183. After it reaches 183, It the C-scan algorithm, it goes to the end of the disk and then it traverses. No, it's not going to the end. Here it's going to traverse. So where it's going to traverse? What is the pending thing? Pending is 14 and 37. So it goes to 14. Because you remember that the disk will be served in the forward in one direction. So go to 14. After serves 14, it goes to 37. So this is the idea. So the direction is like this and like this. Okay. So the distance from 183 to 199 is not covered. So it will be lesser. The total head movement will be reduced in this C-look algorithm. And also it's not going to reverse back to 0. It reverses back to the beginning request 14 and then 37 and it continues. So the requests are served in this one direction. When it is while traversing to the beginning, no request is served. Traversing to the beginning, no request is served. So the total head movement so from 53 to 183 only. And while it traverses back, it's a return trip. It's not going to be counted. 183, 14, it's not counted. From 14 to 37. So when you subtract these two numbers, you get 130 here and you get 23 here. When you add them, you get 153 cylinders. So this is the total head movement for C-look algorithm. So the C-look algorithm is very close to C-scan algorithm. Only the difference is in C-scan, when it moves in one direction, it goes to the end of the disk and it traverses to the beginning of the disk. That's the difference. Here in C-look, it goes to the last request and it traverses to the beginning request. In the beginning, what was the first request? It's not going to the beginning, extreme beginning of the disk, or it's not reaching the extreme end of the disk. So that traversal, the distance is reduced. Okay, because in the previous case, we got the total head movement was, I guess, in C-scan, let me check, I think it was 183 and here is 153. Okay, so 30 cylinders were saved. Okay.